welcome. My name is Julie Roy and I'm a grade 5 teacher. I teach math for immersion students in Moncton. So today, the video, we will talk about multiplying, the beginnings of multiplying. So once students have done the doubling, which was the previous video, they're now ready to look at multiplying. Traditionally, when we were in school, we memorized multiplication. We've learned table, we practiced table, and we pretty much practiced them in order, and we would cross off the ones we know and just try to memorize more. What we found is that students don't learn well that way. When you ask teachers throughout grades K to 12 what's the one thing they wish their students knew, teachers of grade 5, 6, 7, 8, and 9 would all say they wish their students knew multiplication facts. So the goal of this first video is to try to explain to you how I teach multiplication facts for students to ensure that they all know them, they all understand where they come from, and they have strategies to keep refining their answers if ever they would lose how they got their answer the first time. So it's really learning multiplication facts through problem solving, to thinking about what you know. That's always the goal, is to have students thinking about what they know and how what they know can help them know what they don't know. So there are some patterns in the multiplication table, and the first really key one is that multiplication is really linked to the area of a rectangle. So when you try to combine the two, it makes a lot more sense for students. So again, the first multiplication thing we'll see today is multiplying by 2. I don't spend a whole lot of time multiplying by 1 or 0. Most kids get what happens quite quickly, and I wouldn't spend an extensive amount of time on that. But multiplying by 2 I will. Multiplying by 2, I'll just link it to what we just saw, the doubling. So really, for your basic facts, all you have to be able to do for your times 2 table would be to multiply 2 by 2, 3 by 2, 4 by 2, 5 by 2, 6 by 2, 7 by 2, 8 by 2, and 9 by 2. The first activity I do in my classroom is to get students to create a rectangle using linking cubes, and I talk about the dimensions of the rectangle, and those end up being your multipliers. So a 6 here by 2 rectangle would be built this way, and I talk about, link it to their previous knowledge, and some kids have experience using wood, and when we have a 2 by 4, well, what does that mean? Well, 2 by 4 is just the length and width of the top piece of a piece of wood, right? So 2 would be here, and it's usually in inches, and 4 is the length of this side. So then I'll talk about, okay, well, if that's what that is, what would be the area of that particular rectangle? So 2 by 4, what you look at is it's made up of 8. So really it's the same as double 4. Double 4 is your 8. That's how many little cubes would make that rectangle, so its area. Once students understand the model of area for thinking about the multiplication, well then patterns start emerging, right? So I ask my kids, okay, if you made a 2 by 6, that's fine. I'll get them to build off the multiplication table by 2, so build a 2 by 2, 2 by 3, 2 by 4, and all the way up to 2 by 9. And then I'll say, how does knowing your 2 times table help you know the 4 times table? And what you notice when you go from 2 to 4 is that the small length, the length of 2 on your rectangle, when you make it a 4 length, you're really just doubling the area that you have. So if you're 2 by 6, you had 12 linking cubes. Well, when you're making it a 2 by 4, you're really just adding that same rectangle again. So what must happen to the total area of this new rectangle that only has one side that's doubled in length? Well, the whole area must also double, right? So students, when they know their times 2 table, can look at knowing their times 4 by applying what they know with the times 2. So again, when I have 4 times 6, what I would want students to think about is, well, you know what 2 times 6 is? What was that? Well, that was 12. Well, 4 times 6 must be the double, because I just added the same thing again, right? And again, I wouldn't add the same thing in it, I would really talk about doubling the number. And when we double 12, well, we think of 12 as 10 and 2, and double 10 to get 20, double 2 to get 4, so we get 24. And that's how the times 4 table emerges for them. A lot of students will still need to write what they know, and write the 4 times table down, and then write the 2 times table. And the part where you write it is really just to tell your brain what to think about. And sometimes you need to physically write down the instruction for your brain. And that's why I would always start by writing the instruction for your brain for the 4 times table. So again, I would keep looking at all the other times 4. So 4 times 7, well, what do you know? I know what 2 times 7 is. That's 14. What's a double of 14? Double of 10 is 20. Double of 4, 8. So 4 times 7 must be 28. And again, when we look at 4 times 8, this seems to be a tricky one for most kids, because when you do 2 times 8, your answer is 16. And when you double 16, your second digit here, your units digit, is higher than 5. And that creates some problem because it's going over 10. That's why it's very important for kids to understand that they're really doubling. And to double, you need to partition your number in the 10 and the 1s. So double your 10 to get 20, double your 6 to get 12, and that makes 20 and 12, and that's 32. Okay? So that's how the 4 times table emerges, and that's fairly easy for students. And I would get them to practice the 4 times table just in isolation, then link the 4 and the 2 times table together to see if they can differentiate between just doubling and the 2 doublings they'll do in their heads. And the goal again here is to be able to just look at 4 times 8, think about 2 times 8 and double. When students have done this sufficient amount of times, their brain has a path that's very solid, and they'll just get to the answer naturally without having to double first. But the first step in learning is, again, thinking about the doubling. When the 2, the 4 is natural, I ask my students, what do you guess the third one will be? The third strategy we'll see in the clump. Most students at this point say 6 because they haven't really noticed the doubling part. They're still thinking additively, and they think I just added 2 for each number. Okay, so that's very important to say, well, let's go back to a rectangle. What happens with my side? If I had 2 more to make 6, did I double the area? They'll say no. So what do I need to add to really double the area? I had 4 the length of the smaller side. What do I need to do to double it? Well, I need to add 4 more. And when you add 4 more, what you get is the 8 times table. I probably put it this way to really show that I'm really just adding the same part. So again, if what I'm looking at is 8 times 6, and I don't know what the answer to that is, I can always think about what my 4 times 6 was, because I know that 8 times 6 is really just the double of the 4. So what's my 4 times 6? If I, again, forgot my 4 times 6, I can't think of my 4 times 6, you can always go back to your 2 times 6. So your 2 times 6 was 12, your 4 times 6 was 24, and your 8 times 6, double your 20, double your 4, you get 48. So your 8 times table emerges from, again, your doubling. And you really want kids to play with concrete materials in the beginnings so that they really see that you're really looking at the area of your rectangle and it really is doubling when you double the length of only one side. Now, students may have a problem thinking which one they'll double, which ones they won't, but that's okay. That's part of the learning process, and that's why I would always ask them to write it out and really to focus their brain on thinking about the strategies. Okay? So again, if my problem is 8 times 7, this is the one that most adults would have a hard time recalling. What I would ask students to do is think, what do you know? If you don't know 8 times 7, there is something that you know that your brain can go to and help you figure out the 8 times 7. And what they know is 4 times 7. 4 times 7 is 28. What would 8 times 7 be? It needs to be the double, because again, you double the area. Double of 20 is 40. Double of 8 is 16. Right? So you get your 56. Right? So you want your kids to be very strong doublers before they start learning these strategies. If they don't know how to double, that's where you want to go. So this is the strategies for the 2 times table, the 4 times table, and the 8 times table. The next video we'll talk about how you build on those. Thank you.